All right, this is going to be a good one, y'all. I love right triangle trig. Do you? Let's get into it. All right, so the first thing we need to discuss is what is right triangle trig? Well, obviously we need a right triangle. So there's a right triangle. In that right triangle, let's label one of the two angles that are not 90 degrees, such as this one. Let's label that theta, okay? So if that's theta, then that tells me that the angle up here is 90 degrees minus theta. Now, why might it be 90 degrees minus theta? The sum of the interior angles of a triangle, those three angles, should always add up to be what? You know, 180 degrees. Well, if I have a right angle within those three angles, that's already taken up 90. And so the other two angles that are not right angles must add to be 90 degrees. And so if one is theta, then the other is 90 minus theta. Okay, because if you add those together, you'll get 90. In other words, if the red angle that I've labeled theta is 50 degrees, then the blue one that I've labeled 90 degrees minus theta is 90 minus 50, which is 40. Okay, so let's work this triangle based off of the red angle theta. Now, if you've ever seen a right triangle or have ever discussed a right triangle before, then you should know the hypotenuse is the longest side of a right triangle. And so the side that's across from that 90-degree angle is known as the hypotenuse. So let's go ahead and label that side. Okay, and now the other two sides are dependent on which angle you want to use as a angle of reference. All right, or I like to think of it as the angle of interest. So if I'm interested in the red angle, which I've labeled theta, then I'm going to label the sides of my triangle accordingly. So the side across from theta, I'm going to label opposite. And then that leaves one last side to my triangle. We're going to label that the adjacent side. Okay, so now I have those three sides of my right triangle labeled. Okay, now look at the first letter of each of these sides. So the O, the A, and the H. Those letters are going to help us determine ratios of 6 different trig functions of theta. So what do I mean by that? Well, let's look at 3 trig functions that hopefully you've been exposed to at this point. Sine theta, cosine theta, and tangent theta. Okay, sine theta is equal to the ratio of the opposite side over the hypotenuse. So I'm going to put O over H. Cosine theta is equal to the ratio of the adjacent side over the hypotenuse. So I'm going to put A over H. And then lastly, tangent is equal, tangent of theta, because my angle of interest is theta, tangent of theta is equal to the opposite side over the adjacent side. So O over A. And the other 3 trig functions are known as the reciprocal functions. And so the reciprocal of sine is cosecant. That's abbreviated CSC. So cosecant of theta is equal to the reciprocal of sine. So if sine is O over H, then cosecant is H over O. All right. The reciprocal function to cosine is secant. So SEC is how we abbreviate that, and that's equal to H over A. Lastly, the reciprocal function for tangent is cotangent. So cotangent is COT is equal to A over O. And so you might be thinking to yourself, well, that's a lot to remember. Well, yeah, it kind of is, but what's cool about right triangle trig is we have an acronym that helps us with the first 3 trig functions, sine, cosine, and tangent. And that acronym looks like this: SOHCAH In short, I like to say SOHCAHTOA. SOHCAHTOA. How does it help us with the first three trig functions? Well, SOHCAHTOA stands for something. The S here refers to sine. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and then tangent is the opposite over the adjacent. So if you know SOHCAHTOA, make sure you obviously know the order in which it's spelled. I tell you what, here's a good way to remember the order in which it's spelled. SOHCAHTOA. SOHCAHTOA. Once I say this phrase, I want you to pause the video, say it 5 times. You can try it 5 times fast if you want. Don't get tongue twisted though. And then resume the video. SOHCAHTOA, one way to remember that is some old hippie caught another hippie tripping on acid. It's just a way to remember it. I cannot take credit for making that saying. But I use it all the time. So some old hippie caught another hippie tripping on acid. That's a good way to remember SOHCAHTOA in the order in which it goes. Now, if you can use SOHCAHTOA to find the ratios of the sides of a right triangle for sine, cosine, and tangent, then just flip those, find the reciprocal of those ratios, and you'll have the cosecant, secant, and cotangent ratios. All right, so let's look at an example. All right, so let's read this problem. It says, a plane takes off at a 10-degree angle with the ground. When it has reached an altitude of 500 feet, so altitude is 500 feet above the ground, how far has it traveled horizontally after taking off? So after it takes off, it has reached an altitude of 500 feet. Tell me, the point at which it took off, how far has it traveled horizontally? So in order to solve this, we probably want to draw a picture. We have the runway, the plane. It's going to start here. Oh, that's a terrible plane. It looks kind of like a bug. It takes off at a 10-degree angle with the ground. So this is 10 degrees. Once it has reached an altitude of 500 feet, so 500 feet above the ground, so that's this side. How far has it traveled horizontally after it took off? So after it leaves the ground horizontally, so the horizontal distance, how far has it traveled? So we're looking for this. Okay, so we have a right triangle. Here is my angle of interest. I want to label my right triangle based off of that angle. So I know across from the right angle is my hypotenuse. Across from my angle of interest, the angle I've circled in red, the 10 degrees, this 500 feet represents my opposite side. And then finally, X represents my adjacent. So how do we use SOHCAHTOA? Well, notice in my picture, I don't have any information about the hypotenuse, and I'm not asked to find any information about the hypotenuse. I'm given information about the opposite side, and I'm asked to find the adjacent side. So we don't care about the hypotenuse in this particular problem. We care about the opposite side and the adjacent side. Well, if you look at SOHCAHTOA, where is O and A together? Well, O and A is together right here, which tells me I'm going to use a tangent to solve this problem. Okay, so the tangent function is needed to solve this problem. So let's set up our equation. Tangent of 10 degrees must equal the opposite side over the adjacent side. So opposite side is 500 over the adjacent side, which is X. Now we have our equation. We want to solve for X. So algebraically, we need to multiply by X. my little hint whenever you're solving these types of equations is always multiply by the denominator, whether it's a number or x in this case, because we want to isolate x. And in order to do that, we don't want x in our denominator. We need to multiply the entire equation by x. And so essentially what that's doing is moving the x to the left side in this case, because these two x's obviously reduced to 1. And so now, in order to get x isolated, x is being multiplied by tangent 10 degrees. And so we would simply divide by tangent 10 degrees. Okay, and now we have x equals 500 divided by tangent 10 degrees. All right. Now, obviously, that would be representative of the exact horizontal distance after taking off. But if we want to interpret this, or we're trying to express this distance to somebody, obviously we would not say that plane has traveled 500 divided by tangent 10 degrees horizontally after taking off. We wouldn't do that. We would go to our calculator and we would approximate this if it doesn't give us an exact value. So go to your calculator, make sure you're in degree mode, and type in 500 divided by tangent 10 and see what you get. Okay, so I got 2,835.64091. If I wanted to round that to the nearest whole number, I would say approximately 2,836 feet. And there we go. We have approximated the horizontal distance that this plane has traveled after taking off at a 10-degree angle with the ground once it's reached an altitude of 500 feet. So there's so much more that we can do with right triangle trig. I'm about to release a whole nother video involving more right triangle trig, so stay tuned.